And you can also see Professor Kunal Kanti Ghosh, erstwhile from Vinod Gupta School of Management, IIT Kharagpur. And both of us have designed and delivered this course structure for you and have taken sessions to deliver and give value whatever we can, whatever we thought is required to you for this course. Okay, now we have this is the first live session. So what we plan to do is we will take you through the entire subject, entire domain of supply chain management, supply chain analytics, how to do the modeling, and also we have received some questions. We will try to answer them. And in case also during the discussion, if any questions come up, we will definitely try to answer them. Okay. And we will also try to tell you, because some questions are there. Whenever we are discussing a particular topic, if any question fits in that particular topic, we will also immediately answer those questions. Okay. Okay. So let us now parallelly start the sessions, live session. Yeah. Just give. Yeah. And we will. Yes. Okay. Now, see, the subject of supply chain management is not as old as a subject in pure science or mathematics. This subject primarily emanated from the Second World War, the demands of the Second World War, because it was felt that soldiers were in place number one or point number one, and soldiers have to be moved to point number two and point number three. And we had very limited resources in terms of vehicles, in terms of food supplies. So the question of having the best possible solution given so many constraints, that was a necessity during the Second World War. So thus comes up this subject wherein my resources were limited, my demand was many, and so question of optimizing with whatever we have came up, and thus develops the concept of supply chain management. After the Second World War, whatever learnings came up, in terms of learnings, whatever came up, Japan was very quick to adopt these learnings from the Second World War. And so we see the phenomenal rise of Japan immediately after the Second World War in terms of automobile production, in terms of electronics, and many other dimensions and fields. So the concept of supply chain rapidly grew, and a major part of supply chain was being used in the automobile industry. Then the concept of supply chain again spread, and garments industry took over. Today, we see garments industry. The fabric is manufactured somewhere in Southeast Asia. It is stitched somewhere in India. The buttons are being stitched somewhere in Bangladesh or India. And the zippers of the jacket are being procured from Japan, because Japan is known to have the best zippers. And those zippers are being stitched in China. So the shirt or the trousers that we are wearing is a truly global product. So supply chain this is an example of a global supply chain. So today, right after the Second World War, from the automobile industry, today we are seeing the application of supply chain all over. Now the question comes up is that why supply chain, though it is in vogue for the last 70 years now, why are we giving it more importance today? Today we are giving more importance to supply chain because products, whatever you see around you, are being innovated today, imitated tomorrow, and made obsolete the day after. This is the speed with which product innovations are happening. You think of a mobile phone that you are using. Today you are using a particular specification. After 7 days, you find an advertisement in the newspaper or TV with a very different specification. And you immediately think, I am backdated. I need that mobile phone. So that is the lifespan of a product. So the product has to reach every part of the world, if I can say, even before its introduction. So there lies the importance of the speed of supply chain. It has to be very, very adaptive, very, very agile, and very, very aligned to your manufacturing and production systems. To have this speed, to have this agility, we require numbers. We require previous data to model, to mathematically build up a robust supply chain, to program the things. So we need data, we need numbers, we need mathematical techniques, and we need mathematical models to be sure that whatever we are designing is a robust system. And that is where the role of supply chain analytics have come in. And that is why there is a renewed emphasis and renewed demand for supply chain analytics. So this course aimed to cover almost every dimension of supply chain analytics. The way we have planned this course, and you must have seen by now, the way we have planned this course is we took up the flow of a product right from its inception, right from the beginning, till the product is consumed by the customer. So this flow is mapped. And at every stage of that flow, we show you what are the mathematical calculations that are to be done, what are the numeric model, what are the mathematical models that we can build to enable this robust flow. So that is the way we have gone for it. You will go through many books on supply chain. You will go through many courses on supply chain. But this flow, I personally have never come across this flow and the mapping of analytics at each of these flow points. So when this course we thought about, both Professor Kunal, Kanti, Ghosh and myself, we first said that no, let us have the flow diagram ready and then let us map everything, because whatever we are seeing, it is all in bits and pieces. Some supply chain analytics programs, courses, they only speak of inventory control. Some supply chain programs, they only speak of linear programming. But that is only parts of supply chain analytics. So we designed it like this, right from the product forecasting, even before the product has come. From there till the product is consumed and returned. What are the not points? Not points means problem areas. What are the junction points? What are the mathematical models required for this? So that was the idea behind developing this course. Okay, so you see, so I will now take you through what we have taught, what we have already delivered, and what is in store for you. So we started off with the basic concepts of supply chain management. What is risk? What is uncertainty? How uncertainties create problems for supply chain? There was an earthquake in Taiwan, and all the computer assembling units, the hard drives, the RAM manufacturing units, all these chip manufacturing units, everyone suffered. Everyone suffered because earthquake devastated everything. So your entire computer supply was gone. Laptop supply was gone. Only company that survived was Dell. Why? Because they gave the option to the customers that we will upgrade your configuration at zero cost, because the higher range configurations was in another country where there was no earthquake. So you see, what we say is, first we gave you examples of what are the uncertainties, what are the risks in supply chain. Okay. Now then we took you through something called a SCORE model, supply chain operations reference model. Plan, source, make, deliver, return. First you plan, then you source the raw materials, then you manufacture, then you deliver, and if there is a return, return. So if you see, that is what I was talking about right at the beginning. Let us draw the flow of materials. Let us draw the flow of finished products and let us see what are the problem areas and decision areas. Plan, source, make, deliver, return. Okay. So then we took you through the first one, planning. What is planning? Forecasting. How much do we require? When do we require? How much quantity do we require? One of you have asked questions. Where is forecasting? Okay, forecasting, we have clubbed it with another module and you will see it in week 9. And I presume that you have already seen it. You have already gone through that lecture. Okay, forecast, see what is forecasting basically? So we have to forecast first how much will be the sale of finished products because they're interrelated. We have to know how much will be my sale of finished products. Accordingly, I will rent warehouse space to keep those products. Accordingly, in factory, I will purchase raw materials. Accordingly, in factory, I will hire workers. I will see which machine I require. I will see how many work shifts I will have to work. How many vehicles to hire for transporting the raw materials, for transporting the finished products. Will these vehicles be small vehicles or big vehicles? Because big vehicles will not go inside the main city during the daytime. They're only allowed in the evening. What is my product? What is the nature of the demand for the product? So all these decisions, the starting point is forecasting. If your forecast goes wrong, everything goes haywire. If your timing goes wrong, when do you require? Everything goes haywire. So with the forecasting. Now, once the forecasting was done, then we went for supplier selection. This is a very, very tricky area in supply chain and in all domains, even for government purchases. How do you select a supplier? We put, let's say, 10 lakh rupees, above 10 lakh rupees, category A supplier. Below 10 lakh rupees, category B supplier. Now, I am 9,99,999. So I am category B. And someone is 10 lakhs 1 rupee, category A. So immediately there will be a lot of questions. How am I 999,999? How have I become category B supplier? Because crores of rupees worth of purchase is involved. So first thing that we developed was come up with a numeric model to find out the categorization of suppliers. Who is the best supplier, second best, so that nobody can question me. And we are also clear. Okay, so first we went into supplier selection. Next, we went through different models. We showed you AHP model, we showed you TOPSIS model. Sorry, that came a bit later. So first we went to different models. First we showed you the LP metric, showed you rating, showed you ranking. We also showed you clustering of suppliers. We showed you goal programming. We showed you BCG approach. And we gave you the basics of AHP and TOPSIS. All this we did. Now, once we have selected the suppliers, then the raw material will have to come from the factory come from the supplier source to my warehouse. So see, we are going step by step. Moment has to come to your warehouse or to your factory. So transportation. What are the transportation models? See today with fuel costs soaring every day, you have to find out the shortest route. You have to find out the traffic congestion points in a city and then block those traffic congestions. Your vehicle should not go through that area. So today we have to use Google Maps. We have to use real-time traffic jam information. And your mathematical modeling should be dynamic. Today traffic jam is at place A, tomorrow at point B. So your transportation model should be dynamic. It should change. So next we did was transportation modeling. Okay. The max, min, max problems. We did the maximum flow problem. We did the shortest path model. We did the minimal spanning tree model. Now, once your product reaches the factory, It will all not be consumed in one day. It will be in some warehouse. Okay. Now, once it is in some warehouse, okay, once it is in some warehouse, then the question comes, where will I locate my warehouse? Which location? Should it be low cost? Should it be a central location catering to all my sourcing points or distribution points? So which warehouse model will I use? So we learned that, the warehouse location models. Then came another question. Fine, today I have only one warehouse. Tomorrow it might be that my business increases in volume and I will have a second warehouse. So where should I locate the second warehouse? Where should I locate the third warehouse? Now assume that I know that my demand will rise. So already I have a list of priorities. First, warehouse one, first, second, another one, third one. But I don't want to open all the warehouses together. I want to open them one after the other. So can we prepare a priority list? Mathematically, not verbally, mathematically. So can we prepare a priority list? So we learned factor rating method, we learned break-even method, we learned center of gravity model, we learned Ardalan heuristics, we learned transportation cost model, we learned total cost model. We modeled it with GST also. With GST, how will your models change? Okay. Then we went into a very, very crucial aspect of modeling. We went into warehouse space calculation and your economic order quantity, that is inventory control. See, the days are coming when you have to have less inventory. More inventory equal to more space requirement in the warehouse equal to more cost. So we told you, we showed you how you can plan your inventory, the P system, the Q system, economic order quantity, and also economic order quantity with planned shortage. I purposefully keep less stock. This is what all your Flipkart and Amazon today is using. I purposefully keep less stock. When an order is generated through Flipkart and Amazon, the company immediately knows how much order. So they club the orders through an algorithm. They club all the orders together and then they are telling you order will be delivered after 7 days. That means what? They are now getting it from some place or the other. Okay, so they're not keeping it in stock. They are keeping very little stock for same day delivery. Others, they are taking time from you. So these types of models we also showed you. Okay. So what we learned there? We learned EOQ models, simultaneous production and consumption models, the concepts, planned shortage with back order, inventory model for lost sales, multiple item inventory models with constraints on investment. I want to have a lot of inventory, but no money. How to model them? Multiple item inventory models with constraints on space. I don't have space. I need to keep products. Multiple item inventory model with constraints on number of orders. Okay. So then safety stock. How do I calculate? How much to keep as a buffer? Reorder level. My stock is this. It comes down, down, down. Then again I order. What is the reorder level? Continuous review system. Periodic review system. P system, Q system comparison. All this we learned in week 6 and week 7. Okay. Then came up another aspect of strategy. Then came up another aspect of public systems. See, supply chain is not only for commercial organizations, it is also for government and other public utility services. How do you fix bus fares? How do you fix fare for a vehicle? All this we learned. All this we learned in transport costing, fixing fare for public systems. And another one, India's foreign trade logistics using railways. Okay, how do we do trade? India, Bangladesh, India, Nepal, India, Pakistan. That was in week 8. Okay. Now, coming back, we also, after we do this, we need to know the performance of your system. Okay, how you are performing. So that we did under the heading strategic performance measurement. Okay, and that we did in week 5. So there we learned the data envelopment analysis techniques. How do you measure? See, you have 20 warehouses all over the country. Each warehouse is different. Some have less space, some have less workers, some have more people, okay, more orders. So they are not comparable. So how do you compare and come up with a common measure and measure the performance of the warehouses? There we did data envelopment analysis and we did strategic performance measurement. Okay, now then you see next we see once we are all through this, then we need to understand all these are fine. These are the building blocks. So we need to coordinate the entire function of the supply chain. This for the coordination, any deviation, each and every activity has to be tied together, knit together. So any deviation from the time and the cost is a coordination problem. So for that we learned Six Sigma. For that we learned queuing theory. Okay, is it clear? Then we came up in week 11 with risk analytics. I think you are still to do it. How to calculate risk in supply chain. And the last week, the week 12 will be basically modeling the entire supply chain with numbers. Modeling of different full-blown supply chain, right from forecasting to customer consumption. So with numbers. Okay. So this is the broad overview of our supply chain, uh, this modeling and analytics portion. Okay. Now I will now the schema of things is basically that I will now hand over to Professor Kunal Kanti Ghosh. He will speak a little bit on orientation of supply chain analytics. And then whatever questions we have, if we have not answered them, we will answer them. Okay, so over to Professor Kunal Kanti Ghosh.
Okay, thank you, sir. See, Professor Anupam Ghosh has nicely highlighted the important features of the course modeling and analytics of supply chain management. And also we looked at some of the questions that you have posed onto us. And one of the question is, what kind of career opportunities do I have if I go through such supply chain analytics type of courses? See, look, business is highly dynamic, right? And the techniques and the models that we have discussed in our course is with respect to the traditional business environment that was existing at the time when we launched the course, right? It has given you an exposure of what are the main characteristics of supply chains and how to really optimize the different aspects of, say, cost, speed, and related other attributes. But see, any such course is not a tablet that you take that tablet and you become well. See, business is highly dynamic. Look at the post pandemic situation. At this point in time, okay, the business demands, the environment, the entire ecosystem has changed or is going to change. The techniques that you have learned will help you to cope up with the challenges that are there in front of us today. For example, today people are talking of responsive supply chain, agile supply chain, and then finally resilience in supply chain in a post-pandemic era. Now, what is responsive supply chain? Responsive supply chain is that characteristic of any supply network which helps them to adapt itself to the changing demand pattern. Okay. The fundamental idea that Professor Anupam Ghosh has said that for any supply network, we need to balance or match supply with demand. Now, those supply chains which can quickly react to this changing demand pattern at the customer end with a low lead time, they are responsive supply chain. But then, what is agile supply chain? Agile supply chain are those which are in addition to becoming responsive, that means in addition to catering to the fluctuations in demand at the customer side, agile supply chains will also be able to challenge the complexities associated with the disruptions in the supply at the supplier end. That means they are flexible enough to manage the disruptions in supply side as well as cater to the fluctuation in the demand side, right? And resilient supply chains are those supply chains which takes help of analytics, which takes help of uh, your different modeling techniques to change the structure or the action plans of the supply chain in order that the supply chains can become agile. Now, Professor Ghosh started with the need for, say, forecasting techniques. And in our course, we have given you that forecast is a forecast. There will always be an error associated with that. And that standard error of forecast helps us to develop a tolerance band around the expected value that is going to be there for the next planning horizon. And if we can correctly construct that tolerance band, that will help supply chains to become much more responsive because they will know that how to cater to the fluctuations in demand and what will be the amount of fluctuation. Okay, that is one. Second thing, see, if you look at it, previously, all the materials managers or the supply managers, they used to recommend that we should have only one major supplier for, say, parts which are consumed in such a way that the total consumption value at the end of the year is very high. So A class or super A class items were having only one supplier. But imagine a situation in today's context, if the supply source is disrupted due to, say, COVID situation or any pandemic situation or even natural phenomena like tsunami or strikes, lockouts, and due to social distancing, they are saying that only 50% of the employees should come in the supplier factory and all. Now, in today's situation, then only one supplier for one part will not do our job. We need to have multiple sources. Okay. So, in order to have multiple sources, the first thing that you require is to find out alternate qualified suppliers. Please remember the term qualified suppliers. And on what basis you will say that this supplier is my alternate supplier having the requisite quality. Hence, supplier selection models become very, very important. And in that respect, Professor Ghosh and myself, both of us have talked about various techniques for supplier selection, including multi-criteria decision making, where we have basically tried to incorporate several different situations under which the supply disruptions can occur. So if you learn one or two models in a real life situation, you can include all those criteria which are required for finding out the best qualified supplier who can be your alternate supplier. This is one. Second thing, sir talked about planning. Now, why that planning is required? Because in previous cases, see, we used to have buffer stock or safety stock to take care of the fluctuation in the demand pattern as well as fluctuation in the lead time, basically the fluctuation in the arrival pattern of material. But in today's situation, okay, this arrival pattern is not only a function of the variation in lead time, but also it takes into consideration different other situations which are being guided by the post-pandemic environmental conditions. Now, under this situation, planning is very important because here, instead of only having the safety stock, you need to have buffer capacity. That means excess capacity you must take into consideration. And here, maybe at a later point in time, we will introduce some more advanced models based on theory of constraints, and where they are talking about instead of keeping extra stock, we should have extra buffer capacity. Okay, so capacity planning is one which is very important, which we will talk in subsequent modules. Again, see what is happening, that today people, that site selection, Professor Ghosh was mentioning about facility location, that site selection. See, today, under this post-pandemic situation, in order to become highly responsive, many organizations, they are basically locating their final assembly site near, very near to the customer site. Okay. And they are trying to assemble the final product as late as possible, which is basically one particular strategy in supply chain. So in order to do that, okay, you have to send components, sub-assemblies to that particular place where it is going to be assembled. Hence, transportation planning is also very, very important. So that is why I'm saying that these analytic techniques will help you to become not only cost efficient, but the savings that you will generate will get will be so much that it will outweigh the extra cost that you make to make the supply chain much more resilient. Okay, so there is a strategy called postponement strategy in supply chain, wherein we talk about assembling the final product as late as possible. But how much late? How do we make it happen? These are all some advanced concepts of supply chain planning and strategy formulation, which is an extension of the SCORE model, which we will discuss in our next course if we are in launching it in future. But you see, the techniques, the approaches that you learn from this course will remain the same. And today, you see, Sir talked about warehouse management. It's a very, very important topic. And particularly in the context of this pandemic scenario, the social distancing and all, the warehouse layout will be very, very important, including the new criteria that needs to be maintained, that how much distance must be maintained. And you see, they are incorporating a lot of automation in the warehouse. Not only that, their entire supply chain is getting automated. And that will be the future scenario, wherein, robotics and other analytics techniques will play a very important role. For example, they are talking about, see, all those supply chains which have gained a little bit of maturity, they are now talking about complete digitalization. You look at, Hindustan Liver, they, get a lot of agricultural products as raw materials and components for manufacturing edible oils and other food items, and even for cosmetics and other things. Now, see, through satellite linkages and all, they have basically connected their sources of supply with the manufacturing site. And if there is any problem, and they say that the supplier is facing problem, or there is a lot of coronavirus affected places from where they are getting the items, so what will happen? The lead time will get affected. So through analytics techniques, they can really find out what will be its effect on the total delivery time at the final customer end. So they can previously tell their customer that, look, because of these problems at the supplier end, the delivery time that we had committed earlier will get shifted by this much, just by so many days. Now, see, the customer also becomes aware of the problem. And see, this is a fantastic customer experience, which is possible based on supply chain analytics. All these, machine learning techniques and other algorithms that we will introduce in our subsequent courses will tell you how to really make the customer experience a memorable one, because you have to now take care of all the touch points. Because see, previously people gave a lot of stress on the only manufacturing aspect, but now, from starting from supplier up to the customers, all the touch points need to be taken care of. This is very, very important aspect.
If you permit, we'll now take the questions.
Yeah.
Yeah. Okay. Okay, sir. I will just quickly glance through few questions I can answer. Some will take your
Yes.
expertise. Okay. Some of you have asked for format of final exam question papers. Well, all will be multiple choice questions. Okay. Now the another question has come. Yes, will it be online or physical classroom examination? It will be online. And then which softwares we can use to learn supply chain inventory logistics? Well, there are a few. Excel is a beautiful tool. Number one, you can use Excel. Number two is, if you want, there is a software called Lingo, which is also very, very good. These are softwares which is freely available. That is why I am telling you, and it does pretty good work. Okay. Now, next is final examination details. Well, they will be posted by NPTEL office. Next question is, can we have a case study also included in this course? It will implement, yes, definitely, as Professor Kunal Kanti Ghosh has mentioned, we will have all these things when we are going for if we at all go and if we get the permission, the second part of modeling and analytics. Now, the other questions that have come up while we were giving this session, while we were doing this live session, is any suggestion to do some projects or write research papers in this domain? It is all open. I mean, it is all up to you, means it is your work. Nobody is stopping you. Okay, you go through all research papers that are available in the net and other area in internet, etc., and you see what are the current topics going on, see the pattern. Okay, and we are always available in case you require our help. Definitely we'll be there. Acha, can we have a session about logistics planning? I think Professor Kunal Ghosh has just answered your question. It is basically planning based on forecasting. Okay, and you want a session on supply. Acha, sir, I will just club 3 questions and I will put together for you to answer. I'll put together for you to answer. One is, a person wants a session on logistics planning for supplying bare conductor for dynamic condition, and another person wants to know more about single echelon inventory modeling and multi-echelon inventory modeling. Just to take it forward, multi-echelon inventory modeling and single echelon has already been covered in the inventory analytics portion. So you please go through it. And career path after completing this course, I think sir has already mentioned. Sir, so this 2 questions. One is bare conductor logistics planning for supplying for bare conductors and single and multi-echelon inventory planning. If you please take over. After this, we will conclude the session after you answer these 2 questions.
Okay. Yeah, see, multi-echelon inventory planning is basically, several tiers. Now, see, single echelon means there is one tier, but multi-echelon means several tiers, and that we have considered in the inventory control model. So there is nothing to be, elaborated upon. You please go. I don't know whether it has been covered till now or not. You go, if that module is covered, you will get total exposure to that. And the other thing is that
bare conductor,
say inventory planning. See, this will depend from item to item. So see, this requires your basically studying the environment under which you need to do the inventory planning. So until and unless you study the factors that is affecting that inventory, this thing, So it is up to you to basically study and implement the model.
Okay, and sir, one more question was there. Question A is looking for PPTs. Well, you have the video recording with you, and this is for the candidate we are answering. You have the video recording with you. In the video recording, the PPTs anyway are being shown. So I don't think that you will require, because some days back a mail had come that a person wants all the PPTs zipped together and put in a single file. Not this clubbed together and put as a single PPT. Well, that is not possible, not feasible also. You have the video recording, there the PPTs are being shown, so you go through it. The purpose of attending this NPTEL course is learning. So your learning is taken care of. Okay. If you want to use that PPT for other purpose, please take the trouble of typing it along. Okay. Okay. So, sir, I think can we conclude then?
Yes, yes.
Okay, so thank you very much. Thank you from both of our sides, and we will have live session 2 sometime very soon. So whatever questions you have in mind after today's lecture and going through the lecture slides, keep them there and we will answer those questions also.